Hi guys, welcome back to my channel. So today we're going to be looking at proof of divisibility, and we're going to do that using proof by induction. So as a little refresh for our proof by induction, we have 3 steps, but really only 2. So the first step, we are testing when n is equal to 1, or our first case, depending on our domain. The second step we just assume is true, so we just let n equal to k, and again we're just going to assume true. And then the third step, we're going to let n equal k plus 1, and we actually need to test this case. So we are testing this case here, assuming this case here is true, and then testing this case here. Alright, so specifically when we're looking at divisibility, there's a couple of different notations that we need to know before we jump into a question. So if I wanted to say that something was divisible by something else, I could write that as, say, let's say we had 4, we can write 4 is divisible by 2. So this line here just means that it is divisible by, okay? The other thing that we need to know, if we have something that's divisible by 2, we could effectively write that as a multiple, right? So we could write that as some sort of scalar. So I could write this as 4 is equal to 2m. I'm not actually specifically interested in what the value of m is. I'm only interested in the fact that it's divisible by 2. So this is just another way of writing this same information here. Right, let's jump into a question now. Consider the statement that 6 to the power of n plus 4 is divisible by 5, where n is an element of the positive integer set. Okay, so this gives us some information. Oh, sorry, and 0. So in this case, 0 is actually going to be our first case. So our first case, we're going to let n equal to 0. So let's write this notation. So we've got 2 different ways of doing this, remember? So we can write this as 6 to the power of n plus 4 is divisible by 5. So 6 to the power of n plus 4 is equal to 5 times by some multiple. And again, I'm not really specifically interested in what the value of m is. I'm only interested that I can factorize this 5 out of it. Okay, so let's go ahead and let's start doing our proof by induction steps. So step 1, we're going to test the first case. And in this case, we have n is equal to 0 as our first case. So when we have 6 to the power of 0 plus 4, that should be equal to some multiple of 5. So 6 to the power of 0 is 1. 1 plus 4 is 5. So this value is divisible by 5. So we can write that as 5 is divisible by 5. So that means that it's true for our first case, which is good. So step 2. Step 2, remember, we are just going to assume it's true. We're not actually going to test or try to prove anything here. So we're just going to write n is equal to k. So all we're going to do, wherever we see this n, we're just going to replace that. So we have 6 to the power of k plus 4, is divisible by 5, which means, again, we can write this as 6 to the power of k plus 4 is equal to some multiple of 5. And again, I don't really care what the value of m is. I only care that I can factor that 5 out of the front. Alright, so step 3. So step 3, we're going to test the next case. So n is equal to k plus 1. Alright, so let's write this. We have 6 to the power of k plus 1 plus 4 is divisible by 5. So 6 to the power of k plus 1 plus 4 is equal to some multiple of 5. And I've written p here, and again, I don't really care what the value of p is. I only care that I can factor that 5 out of the front of it. So what I'm going to do now is I'm going to try to substitute some information in here from my previous step. So when I have this 6 to the power of k plus 1, that's the same as saying 6 multiplied by 6 to the power of k plus 4 is equal to 5p. So I'm going to use this information here now. I'm going to rearrange this. So I have 6 to the power of k is equal to 5m take 4. And I'm going to substitute that information into here so that I have 6 to the power of 5m take 4 plus 4 is equal to 5p. Okay, so I'm going to expand my brackets now. We have 30m minus 24 plus 4 is equal to 5p. 30m take 20 is equal to 5p. And I can now factorize 5 out the front, and that's what I wanted all along. I don't really care about these values, remember, I'm just interested in being able to factor 5 out. Okay, so now that I've got this factor of 5 out the front, I can rewrite this statement as 5, 6m take 4 is divisible by 5, because if I divide that by 5, that's going to divide into this term here. So the statement is true for n is equal to k plus 1. So we've proven this true by induction. So we now need to write our inductive statement. So we were able to show that our first statement was true. We were able to show that our n is equal to k statement is true, assuming that our previous case is true. And so therefore our statement, 6 to the power of n plus 4, is divisible by 5, excuse me, by induction for our specified domain. Alright, this is a little bit of a tricky concept, so I'm going to do another example. Use a proof by induction to demonstrate that n to the power of 3 take n is divisible by 3 for the domain n is greater than 1. Okay, so again we're going to start off step 1. So step 1, we are going to find if this is true for our first case. And looking at my domain here, n needs to be greater than 1. So in this case, I actually need to let n equal to 2, because this is going to be my first case. Alright, so starting off, we're going to have n to the power of 3 take n is divisible by 3. And so n to the power of 3 take n is going to be equal to some multiple. And again, remember, I'm not really interested in the value of m itself. I'm just looking that I can factorize this 3 out the front. So here we have 2 to the power of 3 take 2 should be equal to some multiple of 3. 2 to the power of 3 is 8. 8 take 2 is 6. And 6 is divisible by 3. So we can write this as 6 is divisible by 3. Therefore, this is true for n is equal to 2. Okay, so step 2. So remember with step 2, we're not actually really trying to do anything. We're just going to let n equal to k. So when we write our statement now, we're going to have k to the power of 3 take k is divisible by 3, or we could write this as k to the power of 3 take k is equal to some multiple of 3. And again, I don't care what the value of m is, I just care that I can factor 3 out of it. Alright, so step 3. So now we're going to let n equal k plus 1. Alright, so in this case what that means is this is going to be k plus 1 to the power of 3 take k plus 1 is going to be divisible by 3. So let's use a different notation here. So k plus 1 to the power of 3 take k plus 1 is going to be equal to 3p. This is going to start getting a little messy, so I'm just going to jump down and write this in. Alright, here we go. So using my binomial expansion, I've just expanded this. So what I'm looking to do, I'm trying to pull out k to the power of 3 take k out of my statement. Alright, so having a look here, I can see I've got a k to the power of 3 here, and I've got take k here. So what I want to do now is I want to replace that information with 3m. So we're going to write that as 3m. Alright, so simplifying the rest of my information now, we have 3k squared plus 3k, and then that's just going to add to 0, is equal to 3p. And what I can see now is I can factorize 3 from the front of all 3 of these terms. Okay, so what that means is since I can factor out that 3, it is divisible by 3. So let's write our statement. So 3m k squared plus k is divisible by 3. Alright, so we were able to prove that it was true for the first case, and assuming it's true for when n is equal to k, the following case is divisible by 3 as well. So now we can write our inductive statement. So the statement is true for our first case, which is n equals 2 in this case. It's true for n is equal to k plus 1, assuming n equals k is true, and so therefore our statement n to the power of 3 take n is divisible by 3 by induction for our specified domain where n is greater than 1. Alright, so to summarize our proof of divisibility, we are basically using proof by induction to show that things are divisible by something else. And we've shown you a couple of different ways of doing notation that mean divisible by. Alright guys, so I will see you in the next video.